Hello and welcome to Sean Walia Math. This is Sean Walia here. Today our lesson is going to be on common factoring. Let's get to it. So common factoring is the first type of factoring that you always want to attempt when you're asked to factor something, or factor a polynomial. So what is it? Well, common factoring, let's write it out for you. Common factoring is where we look for a value or variable that divides evenly into the group of terms that are sitting in front of you. Okay, so let me show you an example. Say you have 2x minus 8. Okay, first you should recognize there's two terms there. Then that the fact that 2 divides evenly into both of these. So once you've established what that number that divides evenly is, you write it down with an open bracket. Now, 2 times what is 2x? The answer would be x. That takes care of our first term. The second term, 2 times what is negative 8? That would be negative 4. If I distribute this 2, I will be back where I started, and that's why you can never really make a mistake when you factor, because if you always just multiply it out after, you'll be back where you started, and you'll always get it right, okay? Let's take up another example. Say we have 12x minus 3y plus 9z. Here there are 1, 2, 3 terms. Terms are always separated by addition and subtraction, not multiplication. And of course, the common value that divides into these is 3, okay? So we're gonna pull out a 3. 3 times what is 12x? That would be 4x. 3 times what is negative 3y? That would be negative y. And 3 times what is plus 9z? That would be plus 3z. Again, if I distribute that 3 out to the 3 terms, I should be exactly where I started, and I am. So I know I did this correctly. Okay, so these are examples where I common factored out a value. Let's take out an example where I common factor a variable. Okay, so maybe something like a cubed b squared minus 2 a to the 7th b. Now, when we common factor, well, first of all, actually, I'll throw a c in there too, just to illustrate something. So there's 2 terms here. Hopefully you can see that a is common to both of these terms, b is common to both of the terms, but c isn't. So we can only common factor out a and b. Now, what powers do I take out? You take out the lowest power that's there. So I'm going to take out a cubed, and I'm going to take out b to the power of 1, because those are the lowest powers of a and of b in the 2 terms. All right, what do I multiply this by to get this? That would be b. Okay, that's takes care of our first term, minus 2 a to the 4, and we're going to need a c. Again, distribute these, you'll be back where you started, and you have the correct answer. Alrighty, moving right along, number 4 here. We'll take an example that has 3 terms, something like x cubed y to the 4th minus x to the 6th y squared z cubed, and then plus x to the 7th y to the 3 and z to the 5. Okay, so questions you should be asking. How many terms are there? What variables are common between the terms? There's 3 terms. The common variables are only x and y. Z is not common to all 3 terms. So I can only take out x and y. The lowest power of x is 3. The lowest power of y is 2. Open bracket. What do I have to multiply this by to get that first term? It's going to be y squared minus x cubed, and we'll need a z cubed, and then plus x to the 4, y, and a z to the 5. And there you have it. Okay, not bad. Okay, question 5, what we're going to do is we are going to kind of combine the two skills, because in the first couple, I common factored out a value. In the next two, I common factored out variables. So in this next example, what I'll do is I will common factor out both, okay? So an example of that would be 6x to the fourth y. I'm using x's and y's today all the time. You can use a's, b's, you know, whatever you feel like, whatever makes you happy. Okay, so here we go, x squared y. Okay, so 3 terms. Is there a common value that divides into these? Heck yeah, 3 does, okay? Is there a common variable? Definitely, x and the lowest power is 2. Is there a common, yeah, y is common, and we'll take out y to the 1. 3 times what? 6, 2. X times x squared to get that x to the fourth. That's good for this one. Minus 5. X, y, plus 8. And we don't need anything else because the x squared y is there. And that's that. We'll do one more example before I common factor out an expression, okay? So an example of this, another example, say -5 x to the fourth. You know what? I'll use a's and b's, okay? I feel bad. You know, I gotta mix it up here a bit. Okay, so -5, a to the fourth, b to the 2, plus 20, a to the 3, b to the 10, and then plus 40, a to the 5, b to the 4. Okay, so this example, it starts with a negative. So I wanted to show an example where I actually factor out the negative as well. Typically, when a polynomial expression starts with a negative, we common factor the negative out. So I'm going to take out the value that divides into all these, which would be -5. A is common, the lowest power is 3. B is common, the lowest power is 2. Okay, times what? Okay, times A. Ooh, that's all I need there. Oh, mistake. A negative times a positive is not a positive. I'm a silly goose. Okay, we definitely need a negative here. Okay, times 4, b to the 8. Okay, minus 8 to get that last term. 5 times 8 is 40. A to the 2 and b to the 2. And Darcy blows, okay? Now, another thing you should have noticed from common factoring is that whatever number of terms you started with, that's how many terms you're gonna have in the brackets when you're done. See, 3 terms, and then 1, 2, 3 terms in the brackets. And if you look at any example we did today, again, the number of terms you start with is the number of terms you end up in the brackets. Okay, so the last example or type of example that I want to show you is when you common factor out an expression. So an example of that, I don't know what number 1 right now. Let's see here. Oh, number 7. Number 7, let's go 2x times 5x minus 2 minus 3 times 5x minus 2. All right, so here, it may not look like it, or maybe it does, I don't know, but there are 2 terms here. Yeah, all of this connected by multiplication, all of this connected by multiplication creates 2 terms. The subtraction separating the 2 terms. What's common to both of these terms? The expression 5x minus 2 is common, okay? So we're gonna common factor the 5x minus 2. We're gonna pull it out in front, in brackets, open bracket. What do we times this by to get this? It'd be 2x. Done. Moving on to the next one. What do I multiply this by to get this? Minus 3. I know it happens so fast, you know, it's like, what just happened there? Well, I mean, essentially I'm saying this times that gave me this, and this times this gave me this, right? So there you go, okay? So we common factored an expression in that example. I'm gonna do one more example and we'll call it a day on this lesson. This is, I don't think you'd even see this in high school calculus. This is like, you know, if you were in calculus and you were asked to differentiate, and then maybe you had to find the zeros of the derivative, Factoring would be your friend in that example, and maybe you'd come across this monstrosity. I also wanted to do this example because it just kind of it incorporates everything I taught today. Okay, so how many terms are here? The answer would be 2. Okay, these are connected all by multiplication. Same with this. Is there a common value? Heck yeah, 4. I can pull 4 out of 4 and 16. Common variables, yeah, x. I'm going to take out x to the 3. And I'll take out that y to the 2. Common expressions, yes, we've got an x minus 1. We'll take out the lowest power of the expression, x minus 1 to the 2. And we're ready to go. What do we times this by to get this? And it looks to me all we need is an x plus 5 to the 3. Okay, that's that term done. Minus, okay, we need a 4 to get that 16. X cubed to get that x to the 6th. Y cubed. And now I need an x minus 1 to the 1 because x minus 1 to the 2 times x minus 1 to the 1 gives us the x minus 1 to the 3. Okay, so that is the last example I want to do. Thank you so much for tuning in to Sean Wally and Math, and please subscribe or hit smash like if you enjoy my videos. Yeah, and I'm just going to keep posting more and more. If there are any requests or anything in the comments, I'll also provide links in the comments to worksheets that may, if you want to practice these skills. Other than that, again, thanks for tuning in, and have a great day.